happy that you switched to English afterwards because you could have said whatever you want and I could have been a fool here. Hello, everybody. I'm Sam Vanhoutte. I'm a CTO at Codit. Who has not seen enough PowerPoints today? That's good, because otherwise you probably should leave the room, because my intention is to go with a lot of live demos, a lot of demonstrations on how things work. And I only have my slides as a backup for the guideline. And maybe what you also should do is write the my GitHub or Twitter handle down. If you're interested in the code, I will clean everything up and I will publish everything on GitHub as well. So everything you see today will be open source for you to use. Okay. With Codit, we are connecting everything. We are connecting systems, applications, platforms with Azure PaaS, for example, and of course, and this is the talk of today, things. So IoT is very important for us. We are based in Portugal with a nice team that celebrated his 5th year last year. But next to Portugal, we have 7 total countries with 180 people. We only do Microsoft technologies, and that's the only thing that I'll say anymore from a Codit point of view, except that, of course, we're always looking for people to join. Now, with IoT, what you have this very common architecture where everything starts with the devices, but no one is doing the devices as such. Everyone wants to be on the right side, because on the right side, that's where you create the value. That's where Microsoft Azure has a lot of services in the cloud to do the big data, to do integration, and so on. So what I'll talk about today as technologies and as concepts is about Edge. I'll talk about the whole ingestion, because that's where IoT Hub has its place. And then a lot of things I will do is all about streaming data, streaming processing of intelligent queries and so on, and the integration with your backend systems. So that's the concept of today. I made a very nice animation on the plane because you're not connected anyway. So that's when you have things like that. And that's what I will do today. I will talk about a scenario like this. So what we have a traffic camera on, let's say, the one side. And on the right side, you have another traffic camera. The only thing that the traffic camera is doing is actually scanning something and sending something to the cloud. So what it does, it detects the license plate. It detects, of course, the time. It sends which country the car is, and the make, and the color. Of course, I have simulated everything, and you will see strange colors because I used the console colors as a thing. So you will have a cyan car that might be Volvo, but just its simulation. So you have a detection at this side, and you have a detection at the other side. What you also have, of course, is some metadata of this specific traject, because the distance between the cameras will define the speed. The distance between the cameras and the measurement of this time and the measurement of the other time, that's what you use to detect how fast the car was driving. Because this is changing in a lot of countries. I don't know about Portugal, but at least in Belgium, instead of measuring the speed at one time, they measure the speed over a larger distance. And that, of course, makes people drive slower, because in the past, people were just braking very fast when something happened. Is it possible to turn on the discount of it, the counting down of the time? Because I cannot see how long I have. So that's what I have. So I have a lot of things simulated in the cloud there. And I have the 2 concepts where we have Edge. So Edge is everything that happens outside of the cloud, close to the devices themselves. So in a factory, controlling cars and controlling your machines and so on. So what we use the Edge for is to have low latency things close to the things. So for example, license plate recognition that is needed inside that camera. That is something that you could do with cognitive services that you might know. So cognitive services to do things like OCR and license plate recognition. That's something that, of course, you have to execute locally because you want to know fast about these hundreds of cars. You might also want to have something to motivate people that if they are speeding to show something. Like I've had it in France, I was speeding, and suddenly on the top of the highway, it was displayed like, hey, you, and my license plate, you are speeding, please slow down. And it really helps. It's like, whoa. And you can also, of course, show some traffic information. You can show like there will be a congestion and so on. So these things you typically execute on the edge. At the same time, of course, cloud is used for a lot of other things. If someone was detected with speeding, you want to have some ticket automatically sent to them. So you can create a document, look up in the thing the license plate, and send automatically the speeding ticket. You can also use, for example, those measurements not just for speeding, but also to detect suspicious cars that have been raised as like, this is from a terrorist, this is from someone else, this has been picked, and so on. So you could have a list that looks up things and notifies the right agencies. And you can then, of course, do, let's say, some trend analytics to see, oh, the traffic is slowing down in general, so maybe we will have to alert people and so on, or redirect people and notify people on the thing. So that's where you have the different concepts of edge and cloud, and both of them are using AI, if you want, or data analytics. Now, the first thing I will show, and that's the introduction, but now I'll go in the demo. The first thing I'll show is Azure IoT Edge. Who in this room has been looking and playing with IoT Edge so far? Okay, the Microsoft guys at least. So Edge has the concept of being connected with the Azure IoT Hub. So Azure IoT Hub is a service of Microsoft. And it synchronizes, it's the thing that you have locally. So if you have 5 factories, quite often you will have 5 Edge installations. If I have in my scenario 20 cameras, I will probably have 20 Edge devices. And Edge can be used for connectivity, to use specific protocols like Modbus and so on. But you can also use things like stream analytics, like functions that you push to the edge. So this is what you have. It's all based on Docker. So Docker is running locally, and all these modules talk to each other using, let's say, it's like a copy of IoT Hub in the Docker, which is called Edge Hub, and everyone talks to each other. And that's what I will show now. So this is the entire architecture that I will show in this session. At least I hope I can do that in time. And I will start by IoT Hub and by the IoT Edge. And the rest is for the next step. So this is my Azure portal, where this is the IoT Hub that I have created. On IoT Hub, you can do a lot of things. One of the things that, for example, I have specified is message routing. So all the telemetry that will be sent to the cloud from these cameras will, for example, in my case, be automatically sent to blob storage. That's just with a few clicks. I actually did that 5 minutes before my demo, before my talk. I said, oh, I will add that. It's a few clicks, and automatically, if you would have a look in the Azure Storage Explorer, these files, I probably have to do a refresh here, but the files are just being pushed with all the telemetry data to this storage. So there's a lot of out-of-the-box routing available with Azure IoT Hub. So you can route to things like Cosmos DB, functions, I guess, Event Hub, and those type of messaging. Okay. Now the thing I wanted to show is the Edge thing, and that is here in the IoT Edge. And I hope you guys can see this well enough. So I have my traffic camera Edge 1 running on this machine. So I have a Docker installed, I have the Edge runtime installed, and I will be able to specify, in this case, 5 modules that are running on this machine. And how you do that? You can do that by saying set modules. And every module, in this case there are 3, because the 2 modules that you always have is the agent and the hub. I have 3 modules here. I have the camera, the one that actually simulates these events. I have a display that displays information on the screens. And I have the speeding. It's actually the Edge query that will run locally. I will talk about that soon. So what you have, for example, I will say the camera thing. And then on the right side, you can specify information. For example, people who is familiar with Docker, so containers, this is the format that you typically have to specify an image. It's like a virtual machine that will be taken from the repository, and it will be executed on the Docker instance. So what I'm saying is actually I have a camera with this image, and it has to be always on and so on, and you can set some specific properties. I won't dive into details just because of time. The next thing you can do is then specify what is called routes. So I can specify that all the messages that have been picked up by one module, by one Docker container, will be routed to the other thing. So this is a I hate this syntax. I don't like the syntax, but that's the way you have to do if you use a product. It actually says all the messages, in this case, for example, from the module camera, will be sent into the next module, which is the traffic speeding. And the messages from the traffic speeding will then be sent into the next module, the camera input. So that's the way you chain these modules. And I have the same thing here, where I actually say every message that is being sent by the camera simulator will automatically be sent, and this is the special one, in upstream. And upstream means it will be sent to the cloud. So what you will see now is that all the messages that are running locally will automatically be sent into the IoT hub. So if I go to my code, so if you just use the code as a tool that has a lot of plugins, there's my mouse. If I now click on the containers here, you actually see I have these containers running. These 5 containers are running because of Edge, right? And I can, for example, have a look at maybe the display. Where is the display? Here. I will say show logs. And then here on the right side, I can see the simulation where I have, for example, all the outputs of data that has been going on. What I can do then, I can actually specify in the cloud a different version. And if I would say I have a new version of my module deployed into the cloud, I just change the version of the module on the cloud, and automatically, somewhere in a factory or in India, the other side of the world, the Azure IoT Edge hub gets that connection, and it automatically takes down the new version of that module and it updates things. So this really helps in IoT solutions where you want to control things from the outside. No one wants to build an IoT solution and then have to depend on people driving around to go and fix things, right? So that's where Edge is really helping. I cannot dive into details just because of time, but I wanted to make sure that you at least get the concepts of Edge with this talk, okay? The next thing I want to show is Azure Time Series Insights. This is a very expensive service, but a very easy service to use. So it really helps you in, let's say, data exploration and getting insights. And another service that Microsoft is talking about is Kusto, for example, that is used in application insights. It's somewhat similar. So what I will show here, I will just show how Azure Time Series Insight is being used to explore data. So for that, I just have created an instance. It's just add new Time Series Insights instance. And then actually, once you have it, you can get a view like this. So for example, and this is, the nice thing is that you don't have to specify the structure. Azure Time Series Insight just gets the JSON messages that my camera simulators are sending, and it automatically detects the schema. So I have some properties like the make of the car, is it the BMW, the color, and so on, the speed, and it automatically detects these fields. So on the right side, the left side, I can, for example, add a metric and say, I want to show the speed, and I want to split it by country. And then on the right side, you immediately see, for example, these countries. So you could have a look on how you guys are speeding or not, right? And of course, this is simulated data. So we all know that probably the Germans would be speeding much more than we do. But I couldn't add that in my simulator. But you get the details here. So just Time Series Insights, for example, also allows me to say, oh, this was a special thing, like what happened in this situation. I can just right-click, I can zoom, but I can also say explore the events. And then behind the scenes, and on the right side you see it's streaming, but I will see a list of all the detailed events one-on-one in that time frame. And maybe I picked a time frame that is too high, or the internet connection is a little bit slow, but you will really get a detailed insight there. So let's, instead of 60 minutes, go to 30 minutes, and maybe even decrease a little bit. If I now do explore events, I hope things will be faster. And otherwise, you have to trust me, because live demos, you know, the chance of having every live demo work on an internet connection in a conference is not always extremely high. what I will show is, oh, they are there. So you can see here really in the details, for example, this line, I had, I don't know, the BMW of this car, and you can see dark magenta, if that is ever a color of a car, but you have these things there. What you can also do, you can save some what is called perspectives. So in this case, I have saved some specific queries to show what is possible out of the box with the data exploration things. And again, you have to wait a little bit. Normally this goes pretty fast, right? Except if you do a live demo, then it always goes slow. But you will see, for example, a heat map here where you can really see, okay, which moments in the thing were slower, which were faster. You will see some line graphs and things like that. So I'll just have it load and I'll come back in the next thing afterwards. But I hope the concept until now was clear, because for IoT Hub, for the edge configuration to send data to blob storage, just to have the data exploration and real-time graphs and so on, I had to write 0 code. Of course, for my simulators, I have to write code, but everything else was just out of the box, Azure providing you services that connect everything. Okay, so that's pretty powerful if you ask me. The next thing is probably the more, let's say, integrated thing, where you have a lot of loose services together, but I will try to explain them on why. Because the next thing I will show is Stream Analytics. Someone has used Stream Analytics before? Not a lot of people. The entry, so to take the step as a, let's say, typical SQL or C# developer, the step from there to Stream Analytics to do, let's say, real-time queries is not as high. It's rather easy to get your hands around it. So Stream Analytics allows actually out-of-the-box ingestion from IoT Hub, Event Hubs, and blob storage and so on, where you could say, oh, I have a website that has all the clicks being sent to Event Hub, and it automatically would connect to these things, okay? You can also have reference data. I think SQL is there, but definitely blob storage. And then you have your standing queries. So a standing query is something that you write, and that it's like all the telemetry from that stream is being pushed through that query. And one of the big concepts that is there is that you can have a concept of time windowing. You can say, for example, I want to detect in a window of 5 minutes the average per color, those type of things. And the syntax to write that is in T-SQL with some specific keywords added. Once you have defined your query, you can say, oh, the results of this query, I will now push them to one of these services. And there's a lot of different services. The one that you always use in demos is Power BI. The one that you use in production is typically Event Hub, Cosmos DB, functions, and things like that. So that's pretty interesting again. And the only code that you have to write is your query. The connections with your inbound telemetry or your outbound data sources that you get again just through configuration. And the nice thing is you can also have Stream Analytics queries built in the cloud, but say I want to run them on the edge. So you can build them in the cloud, and then you can say, oh, I will push it to the edge, and I will show that as well. And this was the explanation I gave of IoT Hub, IoT Edge. So this is the configuration of Edge, where I actually say the blue module, the Stream Analytics one, is this one. So all the data that we collect locally from the camera, we will send it to that speed detection query. And if something is detected as a speed, we will show it above the highway to say, hey, you are speeding, slow down. Okay, so that's the concept of Stream Analytics. So what I will show in the next part of the demo is how to build a Stream Analytics query. If a speeding car has been detected, so a car that drives faster than allowed, we will call an Azure function. That Azure function will call event grid. I don't like that. I would love to see Stream Analytics having an output for event grid directly, but that's not there. So we call functions and event grid. Event grid will allow me to just publish events without deciding at that moment what has to happen. I just publish them, and then I allow asynchronous configuration to say other people can subscribe to these events. And in this case, I will use Logic Apps, which is like the workflow engine. And I will say, as soon as an event gets published that a car is speeding, I will kick off a workflow, a Logic app, and then you can do whatever you want. You can automatically create a document, send it to Salesforce, send it to email, whatever you need to do. I hope things are clear enough, because it's a lot of information to grasp. No results to display. So let's just ignore what we have there and switch to the Stream Analytics job. So this is the Stream Analytics job. What you have here is the inputs. So as I said, you can have inputs from different streams and reference data. You have your query, that's where your logic is. You can also write custom functions. And what is also interesting, you can, if you would have a machine learning model defined, you can use the machine learning model in your query as well. And then the interesting part is the outputs. So I'll just go to the query itself, and you will see I will not be able to change the query here because as long as it's running, you cannot change the query. So I would first have to stop, but I'm not planning to change my query anyway, because we're living enough on the edge at this point. What I specified first is 2 data structures. Data structures from my input and the configuration. So this is the stream, all my camera events, and I called it IoT speed events. And this is the information, if you remember, the black thing on my camera that was being sent, that's the JSON that I'm defining there. So that maps the schema. I also have something that I have in blob storage that actually makes a link between the what I call segment. So the traffic segment, like you can the maximum speed limit, the distance between a camera, and so on, because I have multiple speed segments. So I specify these things. And then, of course, the interesting part is where I write my query. So what could be the interesting thing? I just have a select, something that I think most of you know if you've been working with SQL. It's just a select statement. The interesting part is where you have the group by. And maybe I should zoom in a little bit. Here on the right side, you have a concept that is called sliding window. And that's the interesting part. That's very hard to write in SQL or something, because it's a moving data. It's constantly data that is being streamed. And we actually have to calculate the time grouped by the license plate, because cars are crossing each other and so on. So you have to take the first measurement and the last measurement, calculate the duration, and see that the duration is smaller than the allowed duration, and that's the car that is speeding. And I'm doing that with a sliding window. So it's a constantly, I say to Stream Analytics, and I don't know if I can go to the right, but I keep a few minutes in memory, right? So Stream Analytics will keep all the events in memory to make sure that they can, on the fly, calculate these things. And as soon as 5 minutes has been gone, it's like he loses the events and he keeps all the events in memory to query constantly. It's like reactive extensions, but with big data here. That's an interesting one. The timestamp by is also something you have to do, because data can come in from different things. You want a timestamp by the event when it was captured by the car and not when it arrives in the cloud, because there could be lags. So this is just a definition I do of a query. And this is then the select into is where I actually specify I will do a query on the temporary table if you want, and I will insert that into the speeding event hub. And I have another one where I select into the speeding average. So I have several outputs, and I'll zoom out again. So I have an output to the speeding average, the speeding events, and the speeding events hub. It's just 3 outputs, 3 different queries that you can send to different destinations. So I could add something to Power BI and things like that as well. Again, limited in time. So you just have to trust me on those things. What I then did, one of these outputs is actually the speeding events, that is calling a function. So function is serverless, and that serverless function, where's my mouse? That function is actually calling that event hub thing, the event grid, and that is calling on, let's go to the resource group. I just have too much resources here. Here. So I will show you quickly the logic app that is called. So logic app is the workflow type of thing. So there we listen, we have a trigger that listens to the event grid and starts to do those integrations. If time would, or if the internet would be on my side. Ah, shit, now I did a F5, just when it was there. So the speed ticket creation, that's, let's say, the logic app, and you will see that it gets triggered every now and then. So I think we are at that specific time there, and it automatically triggers those messages. Looking at the time, I have to go a little bit faster now, because the next thing I want to show is Data Bricks. It's an extremely powerful service that makes, let's say, the open source community that is around data from Spark, makes it really tied into, let's say, Azure. So Azure now has first-class support for Databricks. So what I will show is I will show some Databricks complex streaming queries, structured streaming queries, where I will show how to detect those suspicious cars. So if I flag a car with a license plate, I can detect it. And again, I could write it to the output to have a logic app triggered off. And I will also show you how to create a dashboard. So this is my Databricks workspace, where I will be able, first of all, to detect the suspicious cars. And this is code, so that I will make open source on my GitHub, as I said. But for example, you have to specify, again, the schema. So it has a lot of similarities with Azure Stream Analytics. It's just much more powerful to have detailed control, but it's also much more complex. For example, you have your IoT thing, so you have and here I say, I will read a table with my suspicious cars. So the suspected cars are in a table. So I have my event hub, my IoT hub, sorry, coming in. I have a table with all the flagged cars, and I will join these in a constant query. It's not like SQL where you have static data and you just do a join for now. No, you actually join these streams, but the data keeps coming in. So with Spark and Databricks, I'm constantly running that query against the stream of events. And then you have to do other things like selecting these things. I have to parse the JSON and so on. And this is where I do the join. So I'm actually saying I'm joining the incoming stream based on the license plate. And if data is being detected, I again make sure that I can output it to an event hub. And that's what I will do in the next thing. Okay. The code will be open source. This is not time enough to go in the details of the query. That's what I will do in let's say in a 1 hour session. But the thing I really want to show now as a last thing, and I will run it already, is a notebook that I have with different things. So it reads the information and so on. And I will group information that is coming in, and I will show and present it as a dashboard. So in the dashboard, you will see live graphs and so on that constantly get updated. And then you can publish the dashboard and have role-based security for these type of things as well. And that takes a while, especially with the internet connection as we know it. But here constantly you see the jobs are running. So these jobs are now being deployed on my cluster. So I have a cluster that I can spin up and spin down automatically when I have the need for the execution of a job, if you want. So that cluster will be spinned up, and it's running and distributing the load across these things. So to do a very simple select star from table, you will get the impression, oh, this is slow, but it's because it's not a traditional SQL database. It's really because things get distributed and so on. So one of the things I might show here is the last query, where I just say, on my messages, I will group them by the time bucket, and then I will say, I will take the average speed. So this should allow me to get an insight on how fast the traffic is going throughout the day. I have other queries that are running. I should go to the bottom here, I guess. And this is then the dashboard that normally gets created, but things are still loading. Again, internet speed is not on my side, but you would automatically see the charts going on the different things. So these are 5 queries that I have running. They are getting deployed, and you would see these things automatically, shown up. Let's go back, and hopefully the query will load. So the thing that I wanted to make clear is that you have different services to do stream processing, real-time processing, and detection of things. What I believe is important is that you can make a real good separation between the actual detection and the publication of the events. Because I have now published these events, and you totally lose couple what has to happen with these events. So a different team can just start working on the workflow integration and so on, and they don't have to know anything about the streaming, the data intelligence, and vice versa. People in the data intelligence, they don't have to become the experts in SAP integration, for example. It's 2 teams, and they actually integrate around, in this case, event grid. Okay? You just have to trust me. I could have created a video maybe to show the dashboard, but you would see the things here live on the screen, as I said. So my time is up. I think the most important takeaway that I have for this session is really that the value of IoT is not just in the connectivity of the devices. It's really in the data, in the intelligence, and in the integration with the rest of your system. If you really look at IoT as a platform that is just having some dashboards and so on, it will never be adopted. No one is looking at the dashboard of a building, for example, to see how warm it is. Everyone wants to have it integrated. They want to have automatic things. If a room is being not occupied, but it's being flagged as not available, that's where you want to do integration and so on. So the value is really in the data and in the integration. That's what I believe. I think Edge is key to have connectivity to the devices, to have management from the cloud. IoT Hub is really powerful, and without the price going up, you constantly get new features and new things being added. And for data analytics, you really have a lot of options, maybe too much options. Also for data storage, you have from Cosmos DB over traditional SQL to a lot of NoSQL alternatives. So you have a lot of options. It's really about picking the right option for your solution. With that, I cannot take questions, but I'm happy to take questions, either outside or at our booth at Codit, at the left side of the stage. And otherwise, thank you for the attention, and enjoy the rest of the day. Thank you.